Welcome to Mobile Coding Academy. Learn principles, build confidence. Let's dive in.
Imagine a single, perfectly functioning login screen on your Android app. You've got an email field, a password field, and a login button, built with the traditional XML view system.
Right, it works flawlessly.
It really does. Yet, according to the stack of Android engineering blogs and architecture docs we're diving into today for you, keeping that perfectly fine screen in the traditional view system might actually be, well, a ticking time bomb.
Yeah, welcome to the deep dive. Our mission today is answering the central engineering question. Why would you move a perfectly functioning screen to Jetpack Compose?
It's a crucial question, especially for the experienced engineers listening out there. The immediate instinct when you see a working screen is just to, leave it alone.
Exactly. If you're looking at your own perfectly functioning XML layouts right now, you're probably thinking exactly what I'm thinking. Why rewrite it?
Yeah, the view system's been around for over a decade. Are we just chasing a shiny new framework?
Well, it's really easy to think that when the screen is simple, but let's look at what happens when that simple screen meets reality. Product managers never leave things alone.
Oh, they definitely don't.
Right, they'll ask for a loading state. So when the user taps login, you now need to disable the input fields, disable the button, and show a loading spinner.
Wait, but even in the view system, I could just write a quick helper function to manage that. Like I just tell the progress bar to show and the button to disable. Why is that a fundamental problem?
Individually, it isn't. The real engineering pressure comes from the next request. Say the backend rejects the credentials, so now you have an authentication error state.
Oh, I see.
Yeah, you have to write another function to explicitly hide the spinner, re-enable the fields, and show an error text view. Then product wants local email validation.
Right.
Then a distinct network failure screen. Then a retry behavior, and like a 30-second lockout after 3 failed attempts.
Okay, yeah, I see the friction. It's like playing a game of UI Jenga. Pulling the show spinner block means you have to remember to carefully push the hide error text block back in.
Exactly.
By the time you add all those retries and lockouts, you're managing so many distinct mutations.
You really are. With the traditional view programming model, which is imperative, you are responsible for manually synchronizing all these mutable UI properties with the application's actual state. And one forgotten move means the whole UI state collapses.
Which leads to the classic stale UI bug.
Oh yeah, where the application's underlying state says, loading is finished and authentication failed, but because you forgot one single imperative command to hide the spinner,
The user sees a spinning wheel and an error message at exactly the same time.
which is an incredibly common, frustrating bug. This is where Jetpack Compose and its declarative mental model completely shifts the paradigm. It solves this by enforcing a core concept: UI equals a function of state.
Let's break that down for a second. Think of it like a strict mathematical function. If x is 2, y is always 4. In Compose, if the state is loading, the UI is always just a spinner. You don't have to manually hide the error state or disable the button. The UI on the screen is just the automatic guaranteed result of that loading state.
That is the big conceptual shift. The imperative approach asks, well, how do I explicitly modify the existing UI to move from state A to state B? The declarative approach asks a fundamentally different question. Given the current state, what should the UI look like? You just describe the screen for a given state, and Compose takes responsibility for updating the rendered UI when those inputs change.
So you eliminate the manual synchronization problem entirely.
Completely, entirely.
But wait, so if you're sitting on a massive legacy code base, does this mean you need to burn down all your old view code and just rewrite everything?
Absolutely not. And that's a really crucial senior level perspective to maintain here. If you have a stable legacy screen that rarely changes, it is perfectly fine to keep it in the view system.
That's a good year.
Yeah, Android allows views and Compose to coexist incrementally. Migration should be driven by, engineering value, state complexity, and maintenance cost, not just because Compose happens to be newer.
That's a relief. You adopt the declarative model where the state complexity actually demands it. But solving this manual synchronization problem introduces a completely different puzzle.
It definitely does.
Because in Jetpack Compose, your UI is built out of functions called composables. Let's say you're looking at your Compose login screen, and the application state changes, like iLoading flips from false to true. Suddenly, the spinner just appears.
Which is exactly what we want. But the gap between that state changing and the UI updating is where the real magic and the real complexity lives.
Right. Because how did Compose actually know that specific state changed? I mean, did it execute the entire screen again just to show the spinner?
Or how did it know exactly what needed to update?
Exactly, what actually causes a composable to recompose?
Now that is the big question.
And that is exactly the engineering mystery you should ponder the next time you stare at a loading spinner. Until next time.
Thanks for learning with Mobile Coding Academy. See you in the next deep dive.